think we're going to get started. Thank you all for joining us this evening. I really appreciate it. Very happy to have you here. I'm WebRTC, CTO of TokBox, and we are very happy at TokBox to host the May edition of TechToks. And we have a particularly interesting topic and speaker this evening, a topic and a speaker very near and dear to our hearts. I'm very happy to introduce Philipp Hancke from Yet, who's going to be talking about WebRTC, and particularly about how to fail gracefully with WebRTC. And just a backstory, when I was introduced to Philipp by Serge Lachapelle from Google. So Serge Lachapelle runs the product for WebRTC at Google. And ever since the first day I met Philipp, I've been trying to feverishly hire him into TokBox. And I've not been successful, so my latest strategy has been trying to entice him with speaking engagements. So we'll see how that works. But for those of you who don't know Philipp, or who goes by Fippo, he's very, very active in the WebRTC community. He writes a whole bunch of great articles. He probably finds more bugs in Google Chrome than the Google Chrome team does. So I'm sure he's got a lot of very interesting insights to talk about today.
Yeah.
So
thanks,
over
Bobby.
to you.
So I want to talk about failure. So WebRTC and ICE, when things don't work, because it's boring when they work. So I'm Philipp, I work for Yet. We've been running Talkie.ai for almost 2 years now, and we have lots of operational experience. And we've seen it fail a lot. So WebRTC is web real-time communications. It's peer-to-peer between web browsers. So it's the RTC peer connection in JavaScript, and you pass around SDP blobs, and you establish a direct UDP connection. So that's the API for it. You create an offer, you set that offer as the local description, then you send it to your peer, and you get an answer back. You set the remote description to that answer, and hopefully it will succeed. So we have our own JavaScript for that, which is a wrapper around that, which is called RTC peer connection as well. And it's slightly easier for us to use, and it contains a number of workarounds we use to work around bugs in browsers. So you can build cool stuff in 5 minutes, which is what Henrik Juretek, the author of Simple WebRTC, said almost 2 years ago. But then Adam Broad, our former CEO, said that he has a slide about things we've learned from Talkie, which says, Jan Lehnhardt is always behind the firewall. And Jan is a big person in the JavaScript community. So, as Chris Cranky put it once, if you're going to launch a WebRTC-powered service for financial gain, then you need to have done everything within your power to ensure it works reliably across as many cases as possible. So Chris isn't with us, unfortunately. I expected him to be here, and I'm very disappointed he isn't. So say hello to ICE. So ICE is Interactive Connectivity Establishment. It's an RFC. And there are some creatures out there that you don't want to meet. So what you're doing in ICE is you exchange something called candidates, which is basically IP addresses and port numbers, some security tokens, and then some magic happens. And at the last IETF, Justin Uberti and Emil Evov and some others gave a presentation on ICE. And basically what you end up doing is you pair your candidates, your local candidates and your remote candidates, and then you're checking each of the pairs. So as I say, it's complicated because you have multiple interfaces, IPv4, IPv6. You might be behind a NAT, behind a firewall, and it's horribly complicated. You never want to write an ICE library. So the peer connection API makes it pretty easy to listen for those candidates. There's this onICE candidate callback, which either gives you a candidate or tells you that it's done gathering with the candidates. And that happens after you call set local description with your offer. This process is called trickle ICE. It's very important for the user experience. because it makes the call setup faster. So on the other side of the call, you need to process incoming candidates, which is done with the PC add ICE candidate function. And it takes the candidate and a success callback and an error callback. And those errors happen, especially in Firefox recently. So it's peer-to-peer. So you have signaling going via a signaling server, and you have media flowing between browsers. Well, if everything works, but there's this thing called NAT. So if computers have public IP addresses or are on the same networks, you get those host candidates, which you can see here as type host. And sometimes, if you're behind a NAT, you need a little help from something called a stun server, and then your media is flowing on that path as well. So far, so good. So stun is session traversal utilities for NAT. If your computers are behind routers, it answers the question, what is my public IP address? And you get something called a server reflexes candidate out of that, which you can see here. So stun servers are really cheap to run. It's just a few bytes per call. There are some free stun servers. And apparently, some people seem to think that because they're a free stun service, you can add 20 of them to your peer connection. But that doesn't increase the chance of the call being successful. It just increases the chance of failure. So the API for that is pretty simple. You pass a iService argument to the peer connection constructor, which is an object with an URL. It is a stun URL, as you can see, and Google is running this free stun server. So it works for 80% of the calls. It does not work if both peers are behind a certain NAT type. And then you need something called a turn server to relay the media. So turn is traversal around NAT using relays. It basically provides you with a public IP address and port, and those candidates are called relay candidates, as you can see here. So turn, important to remember, it cannot decrypt the call, even though it relays the traffic, and it's rather expensive to run. So you need people to pay for the traffic. And apparently it's the part where web developers don't like WebRTC because they need to run a turn server. I don't know what's so hard about that, but well. So it is used as a last resort by ICE, as a fallback. And also, because you're relaying via a third party, it increases the latency during the call. And it can be part of your firewall in some enterprise settings. And turn servers can talk to each other even. And ICE figures out all of those details for you. You don't want to know about that. So the turn API is similar to the stun API. Instead of having just a URL argument, because you need some kind of authentication, you're passing a username and a credential to that. There's a small problem with that, because your secret credential is not really secret if JavaScript can access it. So what is typically done is that you pass a timestamp at some point in the future as a username, and then do some kind of shared secret mechanism with the turn server. So there's a spec for that, which came up in early 2013, and that is how most of the turn servers are operated today. So it's required for about 15% of the calls, and typically more if you have mobile clients. And there are different flavors, because UDP may be blocked in some enterprise networks. So you have turn TCP, which you can run on port 80 usually, and turn TLS on port 443. Some people even like running turn TCP on port 443. Gustavo says there are not many proxies which disallow that. So turn TCP, it's running media over TCP. It increases the latency, it degrades the quality, even though it's better than back in the old days of Flash and RTMP. The big advantage is it works when only port 80 is open. So for talkies, that's about 20% of the turn calls. that needs that. Turn TLS, as turn TCP, increases the latency, degrades the quality. It encrypts already encrypted traffic, so you need more CPU power to run it. Turn TLS server, but it works when only port 443 is open. That's 4% of the turn calls for us. And turn servers can talk to each other. So you can have your clients talking via TCP to the turn servers, and then the turn servers talking UDP to each other. And still, you can get connection failure, because some networks require proxies for HTTP and HTTPS. That has been his worry in the last year. So blocking voice over IP may be legitimate. There are some concerns like compliance, which mean you cannot just do voice over IP. So now you heard more than you ever wanted to know about a mind-numbing topic of such boredom that Chris had to take a nap just writing this sequence. So if he was here, we would see him asleep already. So thanks for your attention. But forget it, because the important part starts now. So WebRTC is about user experience and applications. And connections fail sometimes, and even in the middle of a call. So deal with it somehow. And this is how. You hook up to the ICE connection state change callback, and then you can inspect the ICE connection state property, the ICE gathering state property, which is less important, and the signaling state. And this ICE connection state can have several states. So it can be checking, completed, connected, disconnected, failed, my favorite one, and closed. So completed is at the initiator, so the person who initiates the call. It means ICE is connected, and in Firefox that means the detailer's handshake starts, or in Chrome it is already done. So browsers are differing there. And the getStates API will allow to query the type of connection that is used. And if you saw the signal keynote, that is the point where you show the video, not before that. Otherwise, you get a black video, and if your CEO is doing that live on stage, that is not good. So at the responder, it goes to connected usually, same procedure as when completed. And you have disconnected. So is this just a network hiccup? And you can check the peer connection signaling state. If it's still stable, it's probably temporary. If it's remaining disconnected too long, you might want to do an ICE restart. And maybe you want to blur the peer image, which is what FaceTime does in that case, if your UX people agree with you. So there's also this state failed. So we're sorry. Somehow it failed. It only happens on the initiator in Chrome, and you need to tell the peer. In Firefox, you get that on both sides. And we're sorry, but maybe we can figure out what went wrong. So if you remember the on-ICE candidate thing, what kinds of candidate did we gather during this? If we use a stunt server, we should have seen one of those server reflexive candidates. If we use a turn server, we should have seen a relay candidate. And never run a WebRTC service without turn. There are a few use cases where that is useful. So you should expect a local relay candidate, or something is not right locally. So if your port to your turn server is blocked, you can detect it that way. And if you remember add ICE candidate, you can do the same here. So what candidates did the peer send us? If the peer uses a turn server, we should have seen a relay candidate, right? Which is a reasonable assumption on the same service. It is getting more difficult if you have a federated thing.
Nobody wants that.
I want that. So it makes things more difficult, so I have to agree with you there. So expect a remote relay candidate, or something is not right on the other side. And that is done before the call is really established. You can look at that and create an expectation. So you can tell the user what is happening while the call is getting established. So if the ICE connection state changes to failed, that means you have a problem. So if you have local and remote candidates, it's most likely not a user problem. And if that happens very often, I would suggest yelling at your turn server operators, because they might have forgotten to run an IP table script and have blocked all the ports on the turn servers other than port 3, 4, 7, 8, and things like that happen. And hopefully you have some kind of monitoring infrastructure that helps you detect stuff like that. And if you have a remote candidate, suggest a problem at the local end. Likewise, if you have a local candidate, suggest a remote problem. And if you have no relay candidates, it's a problem on both sides. So both sides are behind some kind of firewall that blocks them from accessing the turn server. And they're not in the same network, because otherwise they would have used host candidates. So if you're going to launch a WebRTC powered service for financial gain, then you need to have done everything within your power, like I just described, to ensure it works reliably across as many cases as possible. And you can even analyze the cause of the failure and hopefully avoid it in the future, like tell your ops to run their IP table script. And then you have failed gracefully, at least. But I'm not done yet. So if you did not fail, what kind of connection are you using? You can use the getStats API to figure out the local candidate, or in Chrome you can look at the C line. So let's assume you're using a relay candidate, like this one. So you're using turn. Turn comes in different flavors. Is it a UDP candidate, a TCP candidate, a TLS candidate? Well, let's meet the local type preference, which is the lower 8 bits of the priority field, which is this one. So if you do that shift, if you can do that in your head, great. You notice that the lower 8 bits are the number 2. So different browsers in Chrome, that means it's a UDP candidate. And if you have a 1, it's a turn TCP candidate. And if it's 0, it's the lowest preference, it's turn TLS. In Firefox, which doesn't implement turn TLS yet, you have a 0 for turn TCP and 5 for turn UDP. So you can do that for the local relay candidate, but not a remote relay candidate, unfortunately, unless you know what browser your peer is using, and then you can do some guessing. So when I came up with that, I submitted a pull request to the Google's WebRTC sample, and it was horrible code. So I mangled the SDP, I split it into the lines it consists of. I filtered out the candidates and then looked for the IP address. And that code was horrible. So then Justin Uberti said, oh no, I'm not going to merge that, because I have a better way for you. Just check this local candidate statistics we're currently working on. So that was my comment. So if I come up with hacks that are bad enough, I can make them fix my problems. And yeah, he agreed that the initial code made his eyes hurt. Achievement unlocked. Yeah, you still need to accomplish that, right? Yeah. So turn, as I said earlier, is used as a last resort by ICE. However, recently, and I talked about that at Signal yesterday, I've been looking under the hood of some popular service. You can find the articles on WebRTC hacks. So I looked at WhatsApp. And WhatsApp is not using turn as a fallback, but rather they are going for the turn server first. So in WhatsApp, all calls go via the relay server for the first few seconds. Actually, they're calling this relay server a conference bridge, which might imply that in the future they have multi-party calls. Maybe, we'll see. So FaceTime from Apple, it's not using WebRTC, obviously. it goes for the turn server first with some modifications. They're doing some crazy stuff. And Facebook Messenger, which is powered by the WebRTC org library from Google, tries to do something similar. They're using an old relay protocol done by Google. It is not as secure as Turn, I would say, but it is faster than Turn. So they can do that because they control the applications. And for the browsers, they just fall back to standard Turn. So, and then they switch to peer-to-peer after the connection has been established, mostly to reduce the latency of the call and to reduce the load on the turn server. So both your turn server ops as well as your user experience people are happy. And that's likely done to make the call setup latency smaller. So you have less time between getting the connection established and actually hearing the other person's voice. So the thing is that relay candidates will always work. If you get them, they will work. You don't agree, Tsai? Well, we can disagree.
It doesn't work at Amazon.
Yeah.
We're not that far.
So it works today. So this peer-to-peer and turn switch works today in Chrome. And it's a little ugly to implement. You can do it, but it requires an ICE restart. It's not as fast as we would like. However, because Google is listening to me sometimes, it might be the default strategy soon. So they have an issue for that. If you would star that issue so it gets a higher priority for them, that would be great. And that's it. Thank you. Questions?
Is the idea behind trying turn first to establish the call as quickly as possible while you're continuing to negotiate other paths?
Yes, exactly.
So you might start with turn, see if a peer-to-peer connection, and you might wind up staying with turn
Yes.
or transitioning?
Yes, that is what WhatsApp and FaceTime do.
Okay.
And
they're able to implement the transition from the turn to the peer-to-peer in a seamless way without
yes,
any visual
yes.
details?
So I tried that in Chrome, and it is not noticeable. It is good UX, so I'm happy with that. Other than the speed at which this is happening, but that's a detail. Because this seamless switch is the hard part there.
Did you say that WhatsApp and FaceTime always then come off of the turn server?
They try to.
Oh, right. They can't always.
Yeah.
Right.
Sometimes
Okay.
it doesn't work.
And
So-
I thought, but they're not using WebRTC, so turn is not exclusively in the WebRTC world.
Well, turn is something it's a part of the ICE standard. So they're using a standard. Apple has some modifications, which I will talk about on Monday on WebRTC hacks. Yeah. So, of course, Apple is not using the WebRTC org library because they're Apple and they don't do WebRTC. We don't know what they're doing with WebRTC, if anything at all. WhatsApp seems to use some components of WebRTC. So they're using an old library called PJZip, and they just do plain old stun. They don't do any of this fancy new ICE stuff, which is interesting because WhatsApp is owned by Facebook, and they just released Messenger with video calls, which uses WebRTC. So two teams inside the same company using completely different tech stacks.
When you'll be their size, you'll understand.
Yeah.
What does an ICE restart do? Does it
Um,
renegotiate all the candidates?
Yeah, it generates a new set of candidates and tries to reestablish the connection.
Using new RTP sessions, or
No, it's the same RTP session, I think, right? Yeah. Just different candidates.
So for cases that you need turn, do you happen to know whether or not WhatsApp, since it's the first turn at the beginning and then tries calling back to a more direct connection, throughout the entire length of a video call, does it go and keep trying to restart? Or
Yeah.
does it give up after some point?
Well, WhatsApp is more difficult. So they're trying to switch, but they give up after 10, 15 seconds. So what is really nice with WhatsApp is that if you block peer-to-peer in the middle of the call, they just fall back to their bridge again without signaling that to the peer. So sometimes it's easier than doing an ICE restart, because ICE restarts require you to signal candidates to the remote end and do a lot of stuff on the signaling channel again.
For the average case where peer-to-peer works, how long is the connection alive on the turn server? Like how expensive is that?
I would say it's less than 10 seconds in practice. So 10 seconds is more than enough for ICE to complete. So in Chrome, the Chrome team has worked hard on getting the typical connection on the WebRTC thing to be established in less than 500 milliseconds. So that is the...
So they're paying the price of 10 seconds
Yeah.
of turn usage per
Yeah.
call in order to get that fast connection?
Yeah. Yeah, so if you're using some kind of service to run turn servers and you pay them by traffic, that will have an impact on your application.
After these apps renegotiate their ICE candidates, do they also then restart the DTLS key negotiation process, or do they use the same?
Well, so WhatsApp is not using DTLS. They're using the older security description mechanism, so they don't have to care about DTLS. FaceTime is using security descriptions as well, which is good because that mechanism is fast. It doesn't require an additional round trip. And Facebook Messenger is more complicated. So if you're talking to the browser, it does DTLS, because browsers, we have decided that at the IETF in Berlin 2 years ago, must implement DTLS and must not use STS. So that sounds good, because DTLS gives you perfect forward secrecy, which is a nice property. So you can't retroactively decrypt calls. However, what Facebook does on the mobile apps is different, because there they are using security descriptions. Because DTLS sometimes takes a long time to complete when there's packet loss. They want to avoid that because they want the connection to be established very fast to get a good user experience. But that means they have the key to decrypt the traffic. And the NSA might ask them for that key at some point, or some other entity.
So it's easier when you don't go with that.
Yeah.
So I have like way back. I could have read this wrong, but why doesn't Firefox negotiate over TLS for this? It seems like they only did UDP and TCP. Could have read that wrong. But
Oh, for the turn stuff?
it was a while back in the slides, but I was just kind of noticed that they didn't have it.
They do, the turn over TCP, but not over TLS, I think is what
Yeah,
you're
why
saying.
is that?
Simply because they haven't implemented that, right?
Curious if it was
They are waiting for a patch.
Yeah, they're waiting for a patch from that guy. Blame him. So make him work on that, please. Yeah.
Like we haven't done enough for Firefox.
Is there a solution brewing for the UDP, I'm sorry, the must go through an HTTP proxy case?
Oh, Gustavo,
You know what to answer?
you know more about that.
So most of the proxies allows connections as long as you are connecting to port 443. So if your turn server is listening in port 443, it works today with Chrome and Firefox. Depending on the type of authentication that the proxy requires, it could fail on Firefox because it's not supported, the authentication with the proxy. But if your proxy doesn't require authentication, that is most of the cases, it should work as long as your turn server is in port 443.
Yeah, and Google is even working on something called return to enable you to have your own turn server as part of your firewall and then use an application turn server. So they're using turn over turn, which is why it's called return.
In the case of those apps, sorry, I'm asking. In the case of those you were talking about, are the media streams encrypted end-to-end from one client to another, or do they sit in the middle using some special sauce?
It is typically end-to-end encrypted, I would assume. It's hard to tell because for WhatsApp, I don't have access to the signaling because they use their own secret encryption scheme.
Because you mentioned the conference bridge.
Yeah. If they want to use a conference bridge, they need to decrypt, obviously. So they could even do a downgrade attack without you noticing most of the time and record all your calls, which apparently they did in some leaked versions of the application. Some people in Germany found out about that and were very angry. Cool.
Very good. Any other questions? All right, cool, excellent. Thank you, Philipp.
Yeah.
For
Thanks.